Welcome back, Physics 30 gang. This is Unit 1B, Part 2 for vector and scalar quantities. And this material pertains to pages 20 to 24 of the duotang. So for the objectives for this section: define and provide examples of a resultant vector. 2. Explain or demonstrate an understanding of what a resultant vector is, what vector addition is, what vector subtraction is. 3. Add 2 or more collinear vectors algebraically and graphically to determine the resultant, and solve problems involving collinear vectors. So the tail to tip method is how you add vectors together, how you add these various movements. You can almost think of it as like a map direction. If you're having a map for treasure, there's certain steps you have to follow that you have to do, then the result is where you end up being from the starting point. Very similar here. So earlier you learned how to draw a vector. So you would draw the first vector. The second vector would be a continuation of where you left off with the first vector. So we say draw the second vector by placing its origin or tail on the tip or head of the first vector. So you're continuing moving on after the first vector with the second one. If there's a third vector or fourth or fifth, you continue on with this process, adding the next vector on to the last vector where you left off. And then lastly, the resultant is basically the answer from the starting point. Where are you from the starting point? So the resultant vector occurs from the start of the first to the tip of the last vector. So resultant vector always from starting point to finish point. Be sure you star that, highlight that. That's the key point right there. So if we're using an appropriate scale diagram to draw the following vectors to determine the resultant. Now these are all collinear examples along the same line, so fairly straightforward. You could do these in your head, but for this sake we're just going to simply draw them and just to get the process. So vector A is 3 kilometers east, vector B is 5 kilometers east. So determine the addition of those two vectors. So 3 kilometers and 5 kilometers, 3 centimeters, 5 centimeters is relatively decent to put on your paper. So we just use a scale. 1 centimeter equals 1 kilometer. So actually get your ruler out, write down a starting point, 3 centimeters. Then from there you go 5 centimeters, representing the 5 kilometers. And I like to write a little F here for finish. And then the resultant is what you see in red here, from start to finish. And of course we know the answer there is 8 kilometers east, because you could have just simply added these up in your head. Okay, next one, 15 meters west, and vector D is 10 meters east. Determines vector C plus vector D. So here I used a different scale here, 1 centimeter equaling 5. That means this would end up being 3 centimeters. That would be 2 centimeters. It's a little small, but not too bad. So drawing the first vector, 15 meters west, would be 5 centimeters left. So that's indicated by this. Now if you look at this diagram, S is the start. So I drew this black arrow all the way to here, representing 15 meters west. So I would draw that 3 centimeters. Then from this point, turn and go 10 meters east. And of course this is going to be 2 centimeters. So I actually finish here where you see this F written. So start, so once again, to recap, start, this is my first vector. Adding the second vector on from where you left off, boom, you end up here. So the resultant is from start to finish. So if I look at my diagram here, from S to F, it's this little red vector right here. And of course you can see that that is going to be 1 centimeters. And of course 1 equals 5, so using my scale there, that of course would be 5 meters west. Okay, let's look at another example here. So Mr. K decides to drive a scooter across town. He drives 550 meters east on Dudney, then turns around and travels 350 meters west. because he forgot his helmet, etc., etc. What is the resultant vector from the starting point? Be sure to draw a vector diagram and determine the resultant graphically. State the scale used as well. So here, a decent scale to use. I'm dealing with hundreds here, 550, 350. So 1 centimeter equals 100. And you can see what's going to happen here. To represent 550 meters, that's going to be 5.5 times 5.5, so times 5.5 here, so 5.5 centimeters will give me 550 meters. So the first one here, east, so I'm going to start here, draw 550 or 5.5 centimeters. And then you turn around and go 350 meters west, so 3.5 meters west. So I end up right here at this point. So you can see that I indicated that by the S and the F. So started here, did this movement, turned around and did this movement. Notice that I'm putting arrowheads on the tip of each vector. And the start and the resultant vector is from start to finish. So that's that. And of course, measuring that out, I get 2 centimeters. And that works out to be 200 meters east when you factor that scale into it. Okay, number 3, describing the method of adding collinear vectors mathematically. So you can see it's relatively easy with the scale diagram. So if you do it mathematically, if you're listed in a series of steps, so we choose one direction as being the positive movement and the other direction as being the negative movement if there is an opposite direction. And then simply use vector addition to add the negative. Now by that, you can think of it like this. If you have a question such as 550 subtract 350, you can think of that as 550 plus negative 350. Adding the negative. 5 subtract 2 is the same thing as 5 plus negative 2. So we're going to use that little trick here with vector addition here. We're always dealing with vector addition even when we have negatives. Okay, so if we look at the next page here. So as you can see here, sometimes you need to change the direction to change this. Change to the same direction, apply the negative sign. So look here, relatively easy one here. Add the following mathematically. So 15 meters north combined with a 5 meters north. If we think of north as the positive direction, hey, it turns into an easy math question. Positive 15 combined with a positive 5 gives us positive 20. Since positive represents north, 20 meters north is the result. For B, 11 kilometers west and 3 kilometers west, we think of west as being the positive direction this time. Positive 11 combined with a positive 3 gives us positive 14. But since positive represents west, it's just simply 14 kilometers west. This one, 3 kilometers north combined with 5 kilometers south plus 6 kilometers north. So once again here, make one of the directions positive, the other one negative. It doesn't really matter, just as long as you're consistent. So turning that into a mathematical question, plus 3 combined with negative 5 combined with plus 6. And of course, when combining all of that, we'll get plus 4 as an answer. But of course, positive implies north. So 4 kilometers north. Here's one for you to do. Try that one. I just randomly made west as positive, east as negative. See if you can get your answer there. So here if we have positive 6, negative 9, positive 2, negative 1. So we get negative 2 as an answer. And I noted up here, okay, negative means east. so 2.0 meters east. So you can see how that works mathematically. Change your map directions to positive and negative, and once again we're dealing with simple collinear examples here, vectors that lie on the same line. So number 5, with the use of example, describe how you can change a question involving subtraction to an addition question. So think, like I mentioned earlier there, add the opposite. Use plus and minus signs to avoid confusion. So as I mentioned earlier, 5 minus 2 can be thought of as 5 plus a negative 2. So if we look at an example involving that, here we have 50 meters south plus negative 20 meters newtons. Now that's kind of confusing. So if we make it a vector addition question, just like what I mentioned back here, subtract 2 can be thought of as add the negative of 2. And the negative of a direction is simply the opposite. So we can think of it like this: 50 meters south plus negative 20 meters north. Now the negative of 20 meters north is 20 meters south. So you can see how that works. Think of the negative or subtraction as the opposite sign. So there it becomes now back. It becomes a question like in question 4 there. Think of south as the positive direction, so positive 15, positive 20, positive 70, but of course positive means south in this case. Okay, looking at another one here, 10 kilometers east, subtract 3 kilometers east. And again, think of this subtraction as addition, but use the opposite sign. So 10 kilometers east plus the negative of 3 kilometers east. And of course the negative of 3 kilometers east is going to be west. And in this particular example I made east positive, west negative. So mathematically it becomes positive 10 plus negative 3. And of course the result there is positive 7. And of course positive in my question meant east. So 7 kilometers east. So you can see that it's a little trick there that you can use to change vector subtraction into vector addition, and then from there change it into a mathematical method. Okay, the only vocab term here, of course, is resultant vector. Vector that results from the start of the initial vector to the finish of the last vector. So if I have vector A and vector B, draw vector A first. I can put my starting point as an S, start, then the next vector B, I finish there, and then stand back and look at, okay, where am I from start to finish? And then that's the resultant vector. See you next time.